This video is for the solving exponential equations notes. Okay, so we're going to start off, and then here are kind of our rules for doing this. So number one, use the properties of exponents to simplify each side of the equation. We're going to rewrite the equation so that both sides have the same base, and then we're going to drop the bases, and we can set the exponents equal to each other. Okay, so if we start off and the bases are already the same, so here the base is 2, the base is 2. What I can do is I can just, try that again, x plus 1 equals 9. I can set the exponents equal to each other, okay? So here, x equals 8. All right, in this one, the base is 5. So 4n minus 5 equals n minus 7. Okay, so you can just set the exponents if the base is the same. Remember to solve equations. Let me move this where y'all can see. You can do menu 3-1 to solve basic equations. You can use an n on this side. 4n minus 5 equals n minus 7, comma n, remember whatever letter, and it'll solve it. Menu 2-2 will change it to a fraction, but we typed something in wrong. Oh, it should be a 5. Hang on. This should be a plus, not a minus. I apologize. That's a plus sign. And so here n equals a negative 4. Okay. On number 3. So now we've got 3 to the k times 3 to the k plus 2. So when you're multiplying and you've got the same base, you can add your exponents. So this would be 3 to the k plus 2, which would be 3 to the 2k plus 2. So that's what you would set equal. That's your exponent for this side. It would be 2k plus 2 equals 5k minus 1. Again, you can do menu 3-1 to solve. 2k plus 2 equals, sorry, I'm using an x, 5x minus 1, comma x. You can use a k. So k equals 1. And then on number 4, same thing. This is like adding these exponents here. So this would be negative 4 plus 9 equals, it's a v. v plus 4 plus 2v minus 11. And then you can just solve from there. Again, menu 3-1. Menu 3-1. Negative 4 plus 9 equals v plus 4 plus 2v minus 11, comma v. Remember, whatever letter, comma v. And that's still off. So I did something wrong. Let me look. Negative 4 plus 9 is a 5. This would be 3v minus 7. So I'm solving by hand now to check my work. Is 12. So v equals 4. I just typed something in wrong. So again, oh, and I see what it is now. I typed v minus 1 instead of v minus 11. All right, so if you don't have a common base, you can finagle these where you can get a common base. So like here, I've got 6 to the 2x minus 10 equals 36. Well, I can rewrite 36 as 6 squared. Now I have a common base, and I can set 2x minus 10 equal to 2. Okay, and so here x would equal 6. I'm going to skip showing you how to solve equations in the calculator. You should be able to do that by this point. 8. All right, so I need a base of 2. So 8 is the same. Let's see, 2 to the p minus 7. 8 is the same as 2 cubed. So my equation here is p minus 7 equals 3, and p would equal 10. Okay? Here's where things start getting a little bit trickier. So we've got a 7th here. I can rewrite a fraction like this, where this is called a benchmark fraction when there's a 1 on top. 1 over 7, I can rewrite as 7 to the negative 1. And so just to show you that that's equivalent, 1 divided by 7 and 7 to the negative 1 gives me a 7th. If I change it to a decimal, 1 divided by 7 as a decimal, I get the same decimal. So sometimes that's what you have to do. So that would mean 4x plus 11 equals a negative 1. If you solve for x, you get x equals a negative 3. Another way that you can do these, so I know, again, this does get tricky. I'm trying to get a base of 2. So I can take the 32 and I can divide it by 2. And I can break this down. I can prime factor this, is what I can do. 2 times 8. 8 is 2 times 4. 4 is 2 times 2. And you can see here that the prime factors of 32 are all 2. So I can rewrite 32 as 2 to the 5th. And then this is 2m minus 9. Now I have bases that are the same. So 5 equals 2m minus 9. M is going to equal a 7 there. Okay. Number 9. Okay, so number 9, a little bit different again. Trying to get probably a base of 3. Well, 27 will break down into 3 times 9. And then 9 is 3 times 3. So I can rewrite 27 as 3 cubed to the 2x plus 6. And that equals 3 to the 2x. So exponent rules now. Power to a power, you multiply. So 3 times 2x is 6x. 3 times 6 is 18. And now I have the same base, so 6x plus 18 equals 2x. X here is going to equal negative 9 over 2. In this one, the 16 is the same as, so this is 4 to the y plus 2. 16 is 4 squared to the y minus 3. So 4 to the y plus 2 equals 4. 2 times y is 2y. 2 times negative 3 is a negative 6. So I can do y plus 2 equals 2y minus 6. If I solve that one, I get y equals 8. Okay, so it's a matter of just playing around with the numbers. Okay, on this second page, we've got some more examples here that we're going to go through. All right, so on number 11, we've got 125 to the y equals 25. So this one we're going to have to break down a couple times, a couple different ways. So if we do 125 and we want to see if 25 is a base. Other way, divide it. 25 times 5. So 25 is not, I can't use it as a base, but I can use 5. So 125 is the same as 25 times 5, and then 25 is 5 times 5, and then 25 is just 5 times 5. So I can rewrite 125 as 5 cubed, and then to the y, and then 25 is 5 squared. So this would be 3 times y is 3y, and then I could do 3y equals 2. And y would equal 2/3. Okay, so again, it's just manipulating and learning how to change the forms of the numbers. So 16, and what I look at, they're both even, so I know 2 is going to go into them. So 16 is 2 times 8, and then 8 is 2 times 4, and then 4 is 2 times 2. 8 is 2 times 4, and then 4 is 2 times 2. So 16 is 2 to the 4th, and then to the 3x. And then 8, I've got 3 of them, so that's 2 to the 3rd to the x plus 2. Multiply the exponents, so 4 times 3x is 12x. And then this would be 3 times x is 3x, 3 times 2 is a positive 6, so you've got 12x equals 3x plus 6. X is going to equal 2/3 on that one. All right, 13, 4 and 8 are both multiples of 2. So 4 is 2 squared to the 3x. 8 is 2 cubed to the x minus 1. So I would have 2. 2 times 3 is 6x. And then here, 3 times x is 3x. 3 times negative 1 is a negative 3. So 6x equals 3x minus 3. X is going to equal negative 1. All right, back to fractions. So I know fractions can give us fits. So 81. 81 I can break down into 9 times 9, and then the 9s break down into 3 by 3. Okay, so 81 is 3 to the 4th, and then that is to the 2x plus 5. And then 1/3, so remember these benchmark fractions, 3 to the negative 1. 2x. So this would be 3, 4 times 2 is 8x, 4 times 5 is 20. Negative 1 times 2x is negative 2x, so I would have 8x plus 20 equals negative 2x. And so x is going to equal a negative 2 there. And so what I'm going to do is I'm going to leave the rest. If you would like to work through the rest, I'm more than happy to check them for you. But I'm just going to stop there for time. Again, just you're trying to make the bases the same so that you can set the exponents equal to each other.